In this video, we're going to cover the intro to calculus, and specifically, we're going to talk about integration. Okay, so first of all, what is an integral, or what is integration? In mathematics, an integral is a fundamental concept that represents the accumulation of quantities. So what that might mean, in this case, in this video, we're going to cover what that means in the specific context of area under a curve. So over here, we have a function, f of x is equal to 2 of x, right? And this is our curve over here, and in this case, it's linear. Sometimes it's not linear, but for this video's sake, and just to prove why this works in general, we're going to assume that in this case, f of x is equal to 2x, and our curve is linear because x has an exponent of 1. It's not squared, it's not quadratic. Okay, so over here, the easiest way to find the area under a curve for our graph over here would be to draw a right triangle, right? So these two lines will be perpendicular to each other. So this line over here is perpendicular to the x-axis, and that's why this is a right triangle. That doesn't matter too much, but it's nice to know. Okay, so over here, we need to find the area of this triangle over here. And if you recall, the area of a triangle is given by half times base times height, right? So now, in this case, what is our height and what is our base? So this over here on our y-axis would be our height, and this over here on our x-axis would be our base. And let's just box this so you guys don't get confused. Okay, so this is our area formula. Okay, and this is our base, and this is our height. But now we need to think, what is our base and our height? Okay, so over here you can see that the height is specific to the y-axis. We can think of it as sort of a y component to this curve over here, right? So in our equation, it's given that y is equal to 2x, and that's the pretty nice part about it, because it makes all of this much more simpler, because it's really straightforward if you think about it. Okay, so our height over here is equal to y, remember, so it's the y-axis, because over here in this line, there's nothing in the x-axis, there's no displacement happening, so we just take what's the y value of this function, which is y is equal to 2x. Now, let's focus on the base. So just like how we did it for the height, the base doesn't have any displacement in the y-axis. So that means that the base is sort of the x component of our curve over here, right? So our base is equal to x. It's pretty straightforward. And now all we need to do is find this area right here. So I'm going to fill this in so it's easier for you guys to imagine. Right? And now all we need to do is substitute it into our equation for the area formula. A is equal to half times 2x. Let's just put that in brackets. Actually, let's get rid of the x. That's too confusing. Okay, so area is equal to half times 2x times x. Okay, and now area is equal to, so this 2 and this 2, your half and your 2 get canceled out. You get that the area is equal to x squared. Okay, so this leads us back to thinking of integration as sort of the opposite of differentiation, right? So in our last video, we actually discussed how to derive that the derivative of x squared is equal to 2x using a simple slope formula and a few limits. Limit h is approaching 0. So what that means is that in derivation, all you're trying to find is that smallest time, or not necessarily time, so that smallest rate of change where you're trying to find the rate of change where the denominator is the closest number to 0. So let's take the example of velocity, right? So this is a really quick run through. If you want to get more detail, you should go check out that video. But let's say you have velocity, you're trying to find the smallest instantaneous rate of change, basically. So that's what a derivative is. You're trying to find the instantaneous rate of change where this rate of change over here is basically 0. Okay, so that's what that is. And we said that the derivative of x squared is equal to 2x. And over here, the integral of 2x is equal to x squared. So by that, we know that the integration and derivation are opposites of each other. Okay, so over here, we can write f of x. So let's write this. The integral, okay. So the integral of, so the area is equal to the integral of f of x dx, and we got that x squared is equal to the integral of 2x dx, right? But over here, after solving for this, you're actually supposed to get that a is equal to x squared plus c. Okay, so now you're going to be wondering, what is that c, why is that there, and what's the point of it? Okay, so the answer to all those questions is, let's go back to derivatives real quick. As I said before, let's say f of x is equal to x squared, right? And you're trying to find the derivative of this. All you need to say is f prime x. So f prime x is equal to 2x. We discussed this. It's pretty simple if you figure out how to solve it. And again, you can check that out in the previous video. But let's say our function was f of x is equal to x squared plus 5. Okay, in this case, the derivative of a constant is always 0. So f prime x is still equal to 2x. So over here, you can see that number before, the constant is lost in the process of differentiation sometimes. It's kind of confusing. And just to make sure to give respect to the fact that that might have been there, when you are integrating a value, that's why you have to say the integral of f of x dx, and let's say f of x is equal to 2x, right? This is equal to x squared plus c, and it is sometimes the c might not have a lot of value in some problems, but it's always important to include it just so that you don't leave anything out, just to be precise, if you know what I mean. Okay, so that is it for today's video. I hope you enjoyed, and I hope this helps you with your calculus class. Thank you.